Hi, everybody. So I'm just going to do a review of 5A. This is no substitute for rereading or reviewing your own notes. I'm just trying to give you a little something to help you out. What I'm essentially going to do is I'm just going to go through that section of the book. It was chapter 6, was our unit 5, and I tried to align standard 5A to section 6.1. So in 6.1, we should be talking about this standard, which is I can differentiate between different sources of primary and secondary energy and analyze their strengths and weaknesses. So we're going to talk about how primary is the source of the energy, and we'll give some examples as we go through. Secondary is how the energy is transmitted. We've talked about a lot of different sources of energy, like coal, natural gas, those petroleum, fossil fuels, wind, solar, hydro, the more renewable type things, and there were some others as well. And then strengths and weaknesses is the other part of the standards. So there's a lot of things that go in here. We had some good class discussions about this, but environmental concerns is a big one. Cost, how easy it is to use, the land use required, etc. So let's start going through the chapter. All right, so I'm going to focus on section titles and kind of explain the major ideas as we fly through this. All right, so this was just a little intro where we were looking at a solar thermal power plant where the sun's being concentrated onto the center part, heating stuff up and then converting that to electricity. So here the sun would be an example of primary energy, and then when that sunlight is converted into electricity, that would be a secondary energy, because we're not using the sunlight directly, we're transferring it into a different one that we then ship around into our homes and whatnot. Okay, so let's keep going. Human populations and energy use. All right, so we looked around at the start, we looked at just the need for energy and the fact that we need energy for our lives. We looked at how combustion was the first type of energy that people used, where you're basically burning stuff and it's creating a lot of energy and it's creating CO2, which that came up later when we talked about greenhouse effect in the next standard. We looked at how as the population increased over the past, here it's a century, but you could go back even longer, carbon emissions went straight up with it, because the more people there are, the more we need energy, and the main source of energy we use is carbon emissions. We also looked at how different types of energy have changed over the course of the last couple hundred years. And we've seen that the fossil fuels, petroleum, natural gas, and coal, have all been increasing. Only lately has coal been dropping, but it's basically being made up for natural gas. So we're still using fossil fuels. Other things like renewables and hydroelectric, they occupy a very small amount of the energy consumption, although the other renewables has been growing in the last decade or so. All right, so let's start talking about the actual energy sources. So coal is kind of the first major energy source as part of the Industrial Revolution. It's obtained from mines that can often be really dirty. The workers can have some health issues, so that's a disadvantage. It can also create pollution from acid runoff, which leads into section standard C as well. And then when it's burned, it releases not only carbon dioxide, but other impurities. There's actually a lot of coal which the United States government does not allow people to burn because it's just so dirty. But even the cleaner coal is still pretty dirty. Petroleum is a liquid fossil fuel, right? So coal's a solid, petroleum's a liquid. Also called crude oil. This is mainly used in transportation for gasoline and diesel, and it's also used for making products like plastic and things like that. So in this case, the primary energy source, you could say, is petroleum, and then the secondary energy source might be the kinetic energy of your car as you're moving your car forward. Natural gas would be gaseous fossil fuels. This actually is a lot cleaner to burn because it's a simple molecule. It's just 1 carbon and 4 hydrogens. And so when it burns, it produces pretty much nothing but carbon dioxide. So it produces a lot less pollution than petroleum and way less than coal. Which is part of the reason that you see in that earlier graph where natural gas is increasing while coal is decreasing. It's still a fossil fuel, but it's not as bad. Now, what can be a problem, though, is how you obtain it. Especially in the last 20 years or so, hydraulic fracturing has become a lot more common, where they basically inject water and chemicals into the ground to break the ground up to release more of that oil and natural gas, and they pump it up. And so the major problem here is that if there are leaks, which there always are sometimes, even though they do a good job preventing most of them, it can get into the water table and cause pollution. So that's a disadvantage. But all of these fossil fuels are relatively cheap and they're relatively easy to use because you can store them for as long as you want. You don't have to depend on other things. It's completely within your control. Another source of petroleum and natural gas is offshore drilling. So there have been some kind of major leaks. The biggest one is the Deepwater Horizon oil spill in 2010, about 10 years ago. That was in the Gulf of Mexico, released a lot of crude oil into the ocean. So that's a disadvantage. Is even if you're not burning it, if you're just spilling it, that can be a problem. In addition to hydraulic fracturing, another kind of way to get oil is by using tar sands and oil. Canada does a lot of this. It uses a lot of water. It's very water intensive and can create pollution. It's usually only economical when the price of oil is high. Usually it's the cheapest way is just to drill in and get the oil that's already there. But if you've used up all the oil, then you can't really do that, can you? Okay, so here's where the book defines primary and secondary energy. So let's just read this quick paragraph. Today, most electricity is produced through burning fossil fuels. Fossil fuels are primary energy sources because they occur naturally. So primary means naturally occurring. Secondary energy sources are made from primary energy sources. Electricity is a common secondary energy source that can be produced from many different primary energy sources. Okay, so these two diagrams show two ways that fossil fuels can be converted into a secondary energy source. Here it's an internal combustion engine, so you could use this to drive your car. And then here it's a coal power plant. You heat up the water, turn it to steam, turn a generator, and that helps you create electricity. We talked about efficiency of how you calculate that. So energy output over input. The higher efficiency, the better. Some energy is also always going to be wasted. It's impossible to get 100% efficiency because of something we'll study next week called the second law of thermodynamics. Simple calculation there. And then we talked about alternative energy sources. Some of these are renewable, some are not. Renewable means they can theoretically be used forever. So nuclear power is an alternative to fossil fuels, but it's not technically renewable because you are still consuming a resource that will run out. Now, they've calculated that, if we were to switch all to nuclear, we would run out in like a couple millennium. So it's, sometimes people lump it in with renewable when it's not technically renewable. They produce zero air pollution. You still are able to control, turn them on, turn them off. You're not at the mercy of the wind or sun for nuclear. A lot of times people are concerned about radiation. There have been basically 3 cases where radiation has escaped a nuclear power plant, and all the other cases, they haven't had that issue. Those 3 disasters have been Chernobyl, 3 Mile Island, and Fukushima in Japan. Chernobyl being the worst, and then Fukushima and 3 Mile Island. The other issue with nuclear power plant is once you're done using the fuel, it's still very radioactive, so you have to store that somewhere. So you can essentially just build a hole and stick it in there, but you have to make sure that it doesn't get out. All right. So I think the U.S. has a mountain where they put it in, or they were going to. I don't know if they ever finished that plan. Another problem with nuclear power is that it can be used to make nuclear weapons. So that's part of the concern sometimes politically with countries like Iran working on nuclear power. They say, oh, we just want to have clean energy. And then the U.S. goes, sure you do. So that's another complication with nuclear power. But otherwise, it's the same idea as coal. You create heat, you boil water, make steam, turn a turbine, you get electricity. Nuclear has been falling out of favor in the last few years. Solar energy, on the other hand, has been blowing up, especially in California. Although, if we understand, it's taken a bit of a hit because of the trade war with China, because most of our solar panels were coming from China. So here they use electronics with semiconductors and things to basically convert sunlight, which would be the primary energy, directly to electricity. So it takes up tons of land. It's been going down in price. It used to be that it was very expensive. Right now, I think it's getting close to being competitive with subsidies and things like that from the government. It can be actually cheap, but otherwise it's still more expensive than fossil fuels. The big problem, though, is you can't control when you're getting energy. You can't control when the sun's shining. It can't be nighttime and you're like, hey, sun, come out. You can't control when there are clouds or whatnot. Wind energy is a more popular form of renewable energy, but also one you can't control. It doesn't take up quite as much space exactly because you can build things up. There is some noise pollution that people complain about if you're close, so they tend to build them out in remote areas, which suits people fine because remote areas tend to be the ones that are more windy. There are kind of few locations where you get enough wind for them really to be useful, so they tend to build them like between mountains where the wind goes fast or things like that. Geothermal is where they take the naturally occurring heat from underneath the earth. So like, for example, volcanoes have a lot of heat, and they use that heat to boil water, turn a turbine, and there you go. It produces very little air pollution. It's very clean. There's just very little locations where you can build geothermal economically. You basically have to be close to magma on the surface. And so the West Coast has some locations, Hawaii has some locations, but as far as the US goes, the rest of the country wouldn't really work, right? The East Coast, nothing, no geothermal. All right. And then hydroelectricity, they basically take a river, they build a dam, and they trap that water, making a lake, and then they control how much water comes out of the dam, and when the water comes out of the dam, it spins a turbine and creates electricity. So there are some ecological issues for this. It doesn't create air pollution, but it does destroy habitats because you're basically creating that lake. So anything that was trying to live where there wasn't a lake, now there is a lake and it's all underwater. So you're drastically changing the area around there. Also, hydroelectricity has pretty much been maxed out from what I understand, is that all the rivers that would be worth damming have been dammed. And so there's not a lot to grow in this area, at least for the U.S. Other countries which are still developing are investing in this, although not as much as other sources because there's just not as much available. Okay, and then the very last section here, we looked at the effects of carbon emissions. We looked at how we're producing a lot more carbon dioxide, and then we looked at how carbon dioxide, if it's trapped somewhere, can cause an increase in temperature because it absorbs in the infrared because it has these vibrational modes, which was something we tried to emphasize. So it absorbs that infrared radiation, trapping that heat and warming things up, which we'll see in the greenhouse effect in the next section. So that was my quick and dirty review. Hope that was helpful.